Alrighty, we are 5 after, so I'm going to go ahead and get started. I'm here to talk to you now about one of the most exciting pieces. Once you have your NWB files, what do you do with them besides, use them day to day in your lab? You can upload them to the DANDI Archive, which is a big incentive. So I always like breaking this talk into pieces for people who both produce data, how to make a well-annotated DANDI set, how to ensure that your NWB files are following best practices, but then also for all the consumers and reusers of data, how to find good data on the DANDI Archive that might fit your criteria for reanalysis, how to perform quick quality checks in general on a DANDI set to get a just high-level idea of what it's about. And very importantly, how to stream NWB files directly from the DANDI Archive so you never have to download another file again in your whole life. And for people that do both, how to update analysis scripts to read from the NWB versions of the data. We do this very often in helping with labs. Usually it's just a matter of altering a few lines before and after your MATLAB or Python scripts to read from the right location in an NWB file, and yeah. And of course, how to use free computational resources. That's right, free computational resources. I'm gonna start with that one because that usually, that generally gets people's attention. Nothing, nothing. There are some requirements to access them. And no Bitcoin mining allowed, as per that dinner discussion. So, rule number 1, you gotta make an account on the DANDI Archive. Sub-rule, you technically, in order to do that, need a GitHub account. Highly recommend having that anyway, but that means GitHub is the place to start. Then, normally, you would have to wait a day for account approval, but, we were talking to Yarrick earlier. I've given them the heads up. They should probably be very responsive over the next couple of days. So you really should not have to wait longer than maybe a few hours at most if they get busy at their conference. Once your account on DANDI is approved, you just go to hub, that's hub.dandiarchive.org, sign in with your DANDI credentials, select an instance size, and that's the amount of resources, and I'll show you what that screen looks like really quick. Wait a couple of minutes maybe for the server to spin up. It's been getting faster and faster lately. You used to have to wait like, I don't know, maybe 10 minutes, but lately I've only had to wait less than a minute. And after that, you are in. That's it. That's all you have to do for completely free bandwidth that has a direct connection to the archive and all of the resources that I'm going to show you here on the screen. So here I'm just navigating to it. Is it going to complain because I'm already logged in? Let me log out to show you what the panel actually looks like. I have to shut down the server, don't I? Yes. Start up the server. All right, here are your server options. I rarely use Tiny, honestly. Base is usually good enough, and they both spin up equally fast in my experience. But anyway, for really big data handling, I usually jump straight to the large. That's up to 64 gigs, 96, or no, it's up to 96 gigabytes of RAM, 48 cores. There's also the GPU instances if you need any graphical stuff, or GPU-dependent spike sorters, or deep lab cut, or sleep, or any of those things. And new, there's actually a MATLAB instance. You can run MATLAB through MATLAB-like notebooks completely through the hub. I do think you need to sign in with your license information, though, on that. Okay, and that's the hub. And there, it's pretty much an interactive environment, exactly like a local computer, and you just run everything, install software you need. Very intuitive. There's maybe some extra minor details that I will just post some links about in the Neurodata Without Borders chat here. One thing is I often get, and we should make an FAQ for this, is how to make a persistent conda environment on the hub. It's pretty easy to do. Just follow the instructions at the link I just posted on the Slack channel. And another thing I really like is when you launch a notebook on the hub, you can actually select the kernel that it runs on. There's some setup for how you do that, but it's all in these instructions that I posted on the Slack channel. And that's it. That's the hub. So get in there, use it. It exists for you all to use it. Okay, on to the question.
Is the hub also available for staging?
So there's, okay, so for, do I have slides on staging? I think I might. 1 second. Okay, maybe I don't. So very good question and very good timing for that question. So there's actually 2 servers. There's dandiarchive.org and there's staging.dandiarchive.org. The hub is totally independent of both, aside from the fact that it can directly connect to both because they're both on the same AWS region. Now, you'll typically use the staging archive for making a test dandy set. So if you want to put into effect if you want to practice anything that you've learned from this talk later today, go to the staging server and do everything there. You can make as many dandy sets as you want. It's basically for testing and development purposes. It's the main dandiarchive.org that is used for final and official publication of all actual data. Please don't make testing data sets on the official archive. Okay, so on to making a well-annotated dandy set. So when you go to dandiarchive.org and you want to create a new data set, a couple of things are required off the bat. You need a name, a description, and you need to choose the license, but there's only like 2 options. We, by default, go with CC BY4. The name of the dandy set, we generally recommend, you can always change it later, but we always recommend setting it to the name of your publication to find it really easy to find. If someone goes and reads your preprint, and then they go to the Dandy Archive because they saw somewhere at the bottom of the paper, hey, this data is available on Dandy Archive, they're probably going to try looking up the name of the preprint, and so that just creates a direct link that way. There are other ways to set that link. We'll talk on it just a bit. The description can be as rich as you want. We generally suggest starting with the abstract of the preprint to give people a basic idea of what it's about. But you can include all kinds of other information that is maybe data set level, or it applies to all the files in that data set. Details about the experiment setup, existence or non-existence of certain data streams, certain organization practices. It's whatever you personally think would be make your data most easily understandable by an outside party who has no idea what you do. There's also this little button called embargo. So let me explain what embargo means. Embargo is a way of making your dandy set temporarily private. That is, you can use all of Dandy's resources, including the hub, everything I just mentioned, and you can upload data to that data set that you create in embargo mode, but only you and other people that you have added as owners to that data set can actually access anything inside of it. A public user of the Dandy Archive would not be able to even see contents of an embargo data set. They wouldn't even know it exists. Now, let me emphasize again, this is temporary. When you select an embargo data set, it asks you for a grant number. The rule is that data set becomes fully public to everyone when one of 2 things happens. You publish an official paper that uses that data set, or when the grant period expires. When one of those 2 things happens, the embargo data set stops being embargoed and is now completely public. Okay, so once you've created your dandy set, you'll be led to a page that looks much like this. The name of this data set is a metabolic function of the hippocampal, etc. And the description is written partially there, and you can click see more to see more. To modify all other metadata of a DANDI set, you go to the right sidebar and you select the metadata tab, and it opens up a pop-up screen with lots and lots of options. So as I mentioned, you can always edit the title or the description whenever you want. You can add keywords, which I generally recommend, usually the same keywords that you would have set on the actual publication. And so I'll go through some of these most important tabs of metadata one at a time. The first is DANDI set contributors. Cutting off a little bit there. So DANDI set contributors is number one, all the authors on your publication. But it doesn't just have to be them. And I suggest being generous when assigning contributions because there are a lot of roles, actually. Maybe it'd be helpful if I just pull up one of mine that I made in the past to show you how many roles there are. It also includes organizations that aren't people. I'll talk about that in just a second. Oh, this is the published version. I have to enter draft. Okay, so when you enter a DANDI set contributor, you have to choose between one of two things, a person or an organization. We start with a person. Highly recommend adding ORCID IDs because that allows very explicit linkage that, you know, if someone goes to your ORCID page, they could theoretically then be pointed directly towards all of your DANDI sets that you've contributed to. The names have to be, entered in the form last name first. So I would, for example, enter Cody Baker, Cody. The email is only really required for the one designated contact person who is usually the primary uploader of the data set or whoever did the conversion or is most familiar with the experimental setup. You can set links for each person so that when you click on their name on the website, it redirects to like a personal website, that kind of thing. So what I was saying about roles is, yes, author is like the number one role and should definitely include all your co-authors. But there's also many, many other roles. One of them has to be designated as contact person. There might be data collectors. There might be, maintainers or software engineers in the lab. There might be project leaders at your national institution. There might be specific software that you want to cite. What's really the second one that's super duper important after co-authors is funding organizations. So you'll notice on this DANDI set that I've already added and published, I added a lot of organizations. I'll just point out the NIH as like the main one that I assume most people would want to cite. So I highly recommend adding ROR identifiers for these organizations. If you need to find an ROR for some given organization, you can just go to ROR.org. It's like a DOI, but for organizations. And if I just look up like NIH, it leads me immediately to the National Institute of Health, and I just copy that URL and paste it in to the DANDI set metadata. Also added a website and also indicated they are a funder. That is important. And also it's important to include the actual identifiers, the grant numbers from these organizations, if you have them. You know, if it's foundation funding, maybe you won't have a number. But that's important because then on the main page of the DANDI set, they actually get displayed. And those funding organizations really like that because then when they go and look at a DANDI set, they can see, oh, this is great. We funded this. You can also, okay, that takes us on to probably related resources. And that's subject matter. Okay, not always applicable, but sometimes it is. If your study involves, I don't think this study did, so yeah, I'll just go with the snapshot. If your study involves investigation of some kind of medical disorder or a specific brain region, for instance, then I suggest being as precise as possible by cross-linking subject matter with specific ontologies. You can select anatomy ones, which require Uberon, or in this Uberon identifiers, which I was able to find at perl.obolibrary.org just by Googling around a bit. But I'm sure the LinkML people have much better ideas for easier ways of linking that. And then for medical disorders, they need a BioLink SNOMED. I think I went with SNOMED, again, just from like Googling what is the SNOMED for type 2 diabetes in this specific case. This was for a specific experiment where they were tracking like glucose neural activity against glucose concentrations over time. Okay, and that takes us on to related resource, and that I can show you live in an actual data set. This is where you add the DOI link. So you'll notice on the front page of this Dandy set, there's this thing called related resources, and it has the link to the actual paper that I can just get to by clicking that. Hopefully it works. It's loading. It's loading. Just thinking about it. Okay, we'll come back to that. But theoretically, it would lead you to, there you go, Science. There's the publication that someone can then read if. Now, sometimes I mentioned, you know, the way people find this is they read the paper first and they go looking for the data. There's plenty of people now who are doing it the other way. They start at Dandy, they find the data set, and they're curious to learn more. So they follow the link and read the paper. And now someone else in the world has read your paper and may cite it. So that's fantastic. The way you add that is under the Related Resource tab. You add item. It needs the DOI identifier. Just copy and paste that. Give it a title, URL link, like to the science website or to bioRxiv or whatever you feel like. This is a little confusing. It says name of repository. What they really mean there is like the name of the journal of that paper. And then, let's see. And then the resource relation that you would use is the key phrase is described by. And the way you read that is in English. My Dandy set is described by this publication. And likewise for any other resources that you might want to add or cross-link on this. Again, I suggest exploring all of the various options because you could really add as many as you want there. The sky is the limit. Okay, and that involves, question? Sorry, can you say that again?
What's the difference between owners and contributors on a Dandy set?
Organization and contributors.
So an owner has the ability to have data on the Dandy set. Contributor is like an owner. So you can list more contributors.
Right, that's exactly the difference. So you can see it on the main page, so I probably should have just looked there. The owners here, these bubbles, are people that actually have Dandy Archive accounts, and I've actually added them to the Dandy set. They're the only people that can upload content to this Dandy set. They're the only people that can edit metadata on this Dandy set. But contributors are just names of people, links to DOIs, could be any number of people that don't have an account on the archive. So yeah, very good question. Okay, so that's the creation of a Dandy set. The next most important thing is knowing how to upload. So if you go to the documentation area of Dandy, and there's a spot on the left beyond the user guide for creating Dandy sets and uploading data. Step one is pretty obvious, make your NWB files. Step two, we have kind of vaguely mentioned throughout the user days so far, which is inspection of NWB files. And you do this through a command line utility called the NWB inspector. Now, if you've already installed Dandy in order to do your Dandy uploads, this package has already been installed for you. Don't need to do anything else. All you have to do is point the NWB inspector at either a folder that contains all of your files, or it can also run on a single file. And I'll talk a little bit more about the inspector details further on, but suffice to say, the console will report various things to you at this point. If the NWB inspector reported anything that looks of concern, fix or improve as much as you are able and reconvert or modify the files. Once you have your final perfect NWB files, what you do is you download your initially empty DANDI set. You do this with the command DANDI download, all capitals DANDI : 6-digit ID. You'll notice all official DANDI sets have, at least at this point in time, have a convention 000 and then the number of DANDI sets that have been created thus far in time. So, you know, we started off with some of the earlier DANDI sets at 000004, and now we're all the way up to 568. So that will download an empty folder, and then you will perform an organization command. You will navigate into the working directory of that empty DANDI set, and you will call the command DANDI organize, and you will point the command DANDI organize to a folder that contains all of the NWB files that you want to upload. What this command will do is it will rearrange, it will actually create a bunch of shortcuts on your system in a specially arranged folder format that's compliant with the DANDI organization scheme, which is very, very BIDS inspired. Basically, it will extract all of the subject and session metadata from your NWB files. It will give them an organization structure by subject, and then by subject by session, and it'll use as much unique session information as is needed to give it a unique file name. If you ever run the command on your NWB files, you'll see exactly what happens. But at that point, you're almost good to go. You just need to perform one final step, which is validation. And this just makes sure that all the data you're uploading meets DANDI's strict requirements for upload. Hopefully, you run the command DANDI validate on the folder, and everything comes back green. And then you just say DANDI upload. Of course, I should update these slides. We've already CD'd into the directory. The command DANDI upload will then display a whole bunch of progress bars, and you'll be able to actively see in real time how quickly your data is going up to the DANDI set. And when everything has completed upload, you can then navigate to it on the DANDI set. Any questions about how to use the DANDI command line? You're so sharp, Vincent. So, this slide was modified due to some recent changes. As recently as 6 months ago, you would have done that, and you would have done organization after. Nowadays, validate actually ensures that your files follow DANDI's folder structure and file naming convention as well. Okay, so that's the DANDI command line side of things. I'll talk quickly about the inspector. How long do I have for the slot, Ryan? Until 2? Or until 2. Okay, so really quickly, what is the NWB inspector? So we've seen that submissions of NWB datasets to DANDI have continued to rise over the past several years, now up to about 150. Passing strict schema validation in the NWB sense does not always mean that the data is easily reusable by other people. Especially, there are very subtle data engineering mistakes that can sometimes happen, such as incorrect data orientation for any time series type. Ryan emphasized heavily during his tutorial yesterday that all time series must have time as the first axis. But we've seen plenty of output files from the past where there's a transposition that someone was just not aware of. And that immediately is very confusing to someone trying to reuse the data. And in general, lots of data sets I think every data set, even the ones I've made, could always benefit from more complete metadata. Now, you can, as users, read and follow the official NWB best practices, but I'll show you in just a second. It's a lot of work. It's also being constantly updated against DANDI recommendations. Like on a weekly basis, they come back to us with things. So what does the best practices look like? You're welcome to read all of it through. We very carefully write things down, document everything. But at this point, you know, we're into several dozens of individual best practices for various different data types that you happen to be using. So I don't know. It's a bit much, I think, to ask people to go through all of that on their own. So becomes more difficult for individuals like yourselves doing conversions to read all that manually, ensure compliance of your files. What usually otherwise happens is that professional reviewers or curators of DANDI sets, such as Ben, Satya, or myself, will manually download or stream or inspect some of the files from your data set. I'd write up some areas of improvement in a nice little document that we have and email these off to the original submitters. But even we have discovered this itself is a very time-consuming process as the upload rate of files grows every week. So this is why we made this command line tool called the NWB Inspector. It fully automates the best practices tasks and provides immediate autonomous feedback directly to you. The way it does this is we define a collection of check functions that Yark mentioned earlier that map onto each of these best practices, and you can even define your own best practices and your own checks for those best practices if you want. Each check is categorized by an importance level, and there are 3 levels. There's critical. This means your data is potentially organized in an incorrect way. There's only really a handful of those, but they will actually prevent DANDI upload and publication. The next level down is just like a violation of a best practice. It's suboptimal data representation, not necessarily wrong, but it could be improved. And like compression, for instance, is one of those things. If you try uploading a data set that is 20 gigabytes and nothing's compressed, that's a violation. Not severe enough to count as blocking upload, but it's really not ideal. So please compress large amounts of data. The lowest level is the suggestion, just a very gentle improvement to your representation. This is usually things like don't use placeholder descriptions, actually write out something to describe the field, or attach your emission lambdas for OFIS, little things like that. That you might have missed somewhere if you were just using, for example, default metadata on NeuroConf for certain formats. So this will warn you, hey, just go and add this extra little piece of information if it's easy and convenient. And as I mentioned before, it's very easy to use from the command line. If you install DANDI, it comes along with it, but you can also install it standalone. Pip install NWB Inspector, command line usage, like I said, either a file or an entire folder. So far I've not actually shown you what the output looks like, and this is what it looks like. It will print this out either to console, or there's a flag that you can set to save it as a text file somewhere on your system. I think I have a command for that in just a second. But yeah, you have a nice little header field that summarizes how many issues were found in total over how many files, their rough distribution over the importance, some relevance of the version of the inspector used, and then everything below that is the checks in descending order of importance. So you'll see in this example file, it's already been DANDI organized, so we have subject name Corey, session at that timestamp. That's the session ID that they chose for their file. So that file and 38 other files in the folder found an object that's an interval series located in processing behavior wheel moves. And the nice little message here tells you exactly what was wrong: the length of the first dimension of data, does not match the length of timestamps. That is, the data field of that was definitely transposed. So all you need to do is go back to the conversion script, add or remove the data transposition that caused this, and reproduce your NWB file, rerun the inspector. It should now be good to upload. Well, you should also probably fix this other problem, which is negative spike times, which is kind of a weird one. I can talk about it more later if you're curious. Yeah, pretty self-explanatory beyond there. Any questions about the NWB inspector? Okay. So, the cool feature, streaming on Dandy. Thanks for bearing with me for 40 minutes here. No need to download data sets on Dandy, especially when there are some files up there that are a whole terabyte. We're starting to probably add more files that are hundreds of gigabytes. So you can stream directly from the archive. Oh, I'm sorry, we're still in NWB Inspector land. Well, you can run the NWB Inspector with streaming as well. You don't need to download a Dandy set in order to run the NWB Inspector on it. You just call the -- stream flag, and you can get an inspector report very quickly and very easily on the Dandy Hub, just pointing it at an existing Dandy set. So this can be a lot faster than running it locally. Oh yes, and here's the command for saving the report to your system as a TXT file. It's just the flag -- report file path, save my report.txt. I think it also supports markdown files, so you can save it as either TXT or markdown, and it should add the correct types of headers. Not markdown, RST, my bad. Yes, another big thing is for really big Dandy sets, with or without streaming. The scan can be, it's pretty fast on an individual file, but when you have thousands of files, it can be relatively slow. So it has built-in parallelization. You just use the command -- in - jobs, X, where X is an integer, and there's a shortcut of -1 for using all available processes, or -2 for everything except one process if you want to keep one process clear on your system for other things. Highly recommend those. Again, if you spin up a hub large instance with njobs -1, you can scan any data set in like record time, like a couple of minutes. Okay, still have to wait just a little bit for actual direct file streaming. So Dandy search and access. So first thing is searching. Before we stream, we need to find a Dandy set of interest. So obviously the easiest way to get a quick idea about Dandy sets is to go to the main Dandy Archive webpage for public Dandy sets, and there's a search bar there, and you can type in whatever search query you might want, and it will report probably something if it's able to find a relationship. Now they're actively improving this, and I'll show an advanced form here. But what it really does from the web interface is it looks at things at the asset summary level, or at the Dandy set metadata level that have been extracted from file assets. So this includes basic things like the name of the species, which type of approach. We can tell the difference between EC, EFIS, and OFIS pretty easily based on which neurodata types are being used. All the different variables that might show, different neurodata types that might show up in the file, which measurement techniques are even being used within that approach, so on and so forth. Again, these top-level queries look at highest level of Dandy set metadata, so things like the titles, keywords, Dandy set descriptions, which is why it's so important to set good things there. So the basic search function can scan through and more easily associate things to your query. Yeah, so coming soon, the work in progress is more advanced search, and they're always adding more fields to this left sidebar. But soon you'll be able to filter individual file contents based on what kind of species or strain or genotype they use, what file types they are. We would be most concerned with NWB files, and also limit the range of the files if you're looking for really long sessions or really short sessions. That's also something that can potentially be controlled. So I'm sure we'll have a big public announcement when that's actually fully available on the archive. For now, you can access it on the staging server, again, which is for development purposes, at gui-staging.dandiarchive.org/search if you want to play around with it a little bit. And be sure to pass on any feedback you have to Dorota from the Dandy team, who will be here tomorrow. So again, in summary, the web interface is good for a quick glance at general content, casual browsing for something you might be curious about, or finding the Dandy set for a particular publication, or all the Dandy sets that belong to a particular lab, all the Dandy sets that use a particular species. The web interface will lead you to all of those, but it won't help you with a couple of things that you might be curious about, which is presence or absence of identified brain regions. There's an exception unless the creator of the Dandy set those brain regions as keywords or somewhere in the description about the subject matter. It does not definitely help you with presence or absence of exact registered brain coordinates against a common framework like Allen CCFB3 for mice. Doesn't help you with that. Doesn't help you identify the vast variety of behavioral techniques like open exploration versus a maze task, or if virtual reality was involved, or a simple stimulus presentation. Doesn't help you with those, but what you can do is you can implement those types of searches yourselves through the public Dandy API. This scans the metadata YAML files stored on the Dandy archive that programmatically obtain all the information. And so on a local installation of Python, I have some tutorials here. All they require is Dandy and a Jupyter notebook. Launch up a Jupyter notebook. You can even just run this by default on the hub, which is actually the recommended way, because when you go to the hub, I should have spun something up here really quick. Anyone that logs into the hub will actually have access to these tutorial notebooks in your home directory. It's your own personal copy. You can play around with it, try it out as you wish. Okay, we'll check back on that in just a minute when it spawns up. And you can also find the actual link to the search tutorials. Again, all of my slides are posted on the NWB Hackathon website, so you can follow these links in the presentation. But the tutorials themselves, whoops, that's not good. Oh, because it's on a different branch. Oops. Okay, I need to fix that link really quick. These are tutorials that we gave at Cosine this year. And so let me just update that link, and I'll remember hopefully to update the link in the PDF version of the presentation. Okay, so you can see my Jupyter Hub, my Dandy Hub spawned. So I can actually navigate to this folder that should be on everyone's home directory called Cosine 2023 Tutorials. And I'll look up simple asset search and advanced asset search. Let's see, did my slides actually? Okay. Right. So let's see. I recommend going through these tutorials at your own pace. I'll just kind of gloss over them very quickly. But the essential part of the Dandy API, you import this thing called the Dandy API client. You initialize that client, and you're now able to talk to the archive. You're able to fetch available Dandy sets. You're able to ask if those Dandy sets have NWB files. You're able to filter those NWB files by whether or not the species contains a certain key phrase, such as mouse or rat. And critically, this now allows you to do multiple filtering. So you can filter all assets on Dandy then by, say, both species and sex. So if you're looking only for NWB files that have data corresponding to female mice, it's as simple as one extra line in Python to add the extra if condition that sex both is specified and that the name of the sex is female. We have the check for whether or not sex actually exists because older files on Dandy may have been uploaded before it was actually a requirement. But if you filter the Dandy sets past a certain point that they were uploaded, they should all have certain fields like sex and age and species. To understand all the types of queries that you could run on the Dandy API like this, you can consult the metadata files that correspond to assets on the archive. So any field that you see in this gigantic dictionary structure is potentially something that you could create your own set of if conditions or filter for. As you can see, it's quite a lot. Some of it is stuff that's displayed on the actual Dandy website. And some of it is not. So that's the simple usage of the API. I'll skip that one for now. That's a little detail about age. Again, I suggest checking out these tutorials on your own time. Let me know if you have any questions. This one in particular has a lot of built-in kind of gotchas that I solve in the tutorial, but are things to know if you're just building it yourself. And then maybe I'll save this one last coolest one that utilizes streaming for once I've talked about that. Okay, so once you've found a Dandy set that looks interesting to you and you want to investigate the contents, again, I am obligated to tell you, you can download the entire Dandy set using the same command you use during the upload process, just Dandy download, Dandy : the 6-digit identifier. That will download all of the files up. So if that's a really big, not only if the data set has really big files, but if it has lots of really big files, then you're especially in trouble there. Control-C will break you out of the execution of the download. But you can also just copy and paste the URL of an individual file asset that you see on the archive, and it will download just that one file. Once you have the file downloaded, you can do exactly what we've seen all of yesterday with loading the NWB file as if it, now that it's a local thing that you have access to. Oh, right. Yeah, similarly in MATLAB, you already saw yesterday how to read NWB files into MATLAB. The download process is exactly the same because the download process is through the command line. Okay, but the recommended way is actually what I've been harping on, which is streaming. So here's the golden set of commands that are current, up-to-date, most recommended way. So in Python, you'll want to install a couple of things. Or is fspec currently installed with NWB, Ryan? Do you know? Okay, you'll have to install fspec at a minimum. And fspec does all of the magic for you. So you import h5py, you import fspec. You don't have to use caching, but I do recommend it. It makes it faster for reaccessing content over time, and it's not that hard to set up. But this basically makes a temporary folder somewhere on your system where the bytes from the archive stream in temporarily as you're using them. And then you open up a file system on top of the cache. And what you do is, this might look kind of strange. You're not pointing this to an NWB file on your system. You're pointing it to an S3 URL. And this is just a really long string that I'll talk about how to get in just a second. But you get that string, and the S3 URL is essentially equivalent to the NWB file path as if it were on your system. Then you use h5py to open up a file on that file system, and now you're back in familiar territory. Define your reading IO on that file, load namespace is equals true, and NWB file equals io.read. And once you reach these last two commands that you're already familiar with, the whole thing acts as if all those terabytes of data were already on your system, which is still blows my mind how that happens. So how do you find the S3 URL? Well, let's do it live, since the DANDI Archive is not having problems today. If you just navigate to a random DANDI set, you go to the files, you pick a file that looks interesting, you click on this blue info icon, and that leads you to this kind of weird looking page with all this metadata content. This is actually the same metadata schema we were seeing displayed through the API. What we are looking for is the content URL field. Maybe I'll zoom in a little bit there. The content URL field. And in particular, we're looking for the one that has the .s3 in it. Now, all I have to do is copy and paste that, and that's my S3 URL. And then I put that into the previous code, and it would act as if the file's on my system, and I can then read from it. There is a convenience function, though. If that sounds kind of awkward, you don't really want to mess with it, especially if you're iterating over all the files in a data set. I have built a helper function in the NWB inspector. Tools called get S3 URLs and Dandy paths, and it works like follows. You literally just give it the Dandy set ID, that 6-digit identifier. It's, again, fully parallelized under the hood. Not that it takes too long to fetch information, but it still speeds it up by a massive amount. So what you return from this, what you get back, is just a dictionary of one-to-one mappings between those S3 URLs and the files as you would think of them if you had downloaded this. Now, sometimes it's a little more convenient to think of that as the other way around. So a neat little trick in Python, you can easily invert any dictionary by just reversing the order of the values in the keys in that dictionary. So if you run this helper function, create your inverted dictionary, you can now go from your file paths as you would have had them on your local system, and the value in that lookup table will be exactly the S3 URL that you need to pass in to the streaming. This is also possible in MATLAB, and may even seem at the surface to be a little simpler. It's a very strange oddity. It requires a modified form of the S3 path, not the HTTPS version, but basically you take all those numbers and letters after the blob, and you copy and paste them on top of S3:/S DANDI archive/blobs. And that's the S3 protocol version of the URL, which then you can simply pass directly into the command NWB read. Now, this is not actually terribly recommended because from all of our experiments over time, we found that the streaming speeds, even on an equivalent bandwidth, are usually about like 10 times slower, even on the Dandy hub. So highly recommend sticking with Python on that one. And with the 1 minute I have left, I will jump to an actual example of what it's like to stream in practice. So this is like a simple little problem where you want to count the number of spiking units across all sessions, that is all NWB files in a given Dandy set. And so I'm going to do this using the inspector tool method. I'm going to get my S3 URLs. I'm going to iterate over them. And for each one, I'm going to use a slightly different streaming method here called the ROS3 driver, which requires a certain installation. I should probably update this tutorial to use FSpec. But either way, you read the NWB file. You can now access all contents in that file remotely, and you'll get results for each of those. This tutorial works best on the hub because it's already pre-configured with that driver. But you could re-implement this tutorial using the fspec commands that I just illustrated. They use the caching file system and all that kind of stuff. And we're in the process right now, I will mention. If all this seems a little complicated, we are building some super convenient functions that are just called read NWB file that do all of this for you. You just tell us which Dandy set, which file in the Dandy set, and we'll just give it to you. You don't have to think about any of this. Those should be available, I think, in the coming months. So that's how you use the Dandy Archive. Any questions? The question is, what kind of bandwidth do you get on the Dandy Hub? So that depends on your personal bandwidth. So if you're using a local device, it's your bandwidth limit is whatever your usual download speeds are on your personal internet. Throttled, not by the Dandy Archive. It lives on a very nice AWS hosted S3 bucket that I've never seen slow down in my entire life. Now, who knows if that'll change as hundreds and hundreds of NWB users start streaming from the archive on a daily basis. But I don't anticipate any problems. AWS is built to scale to that. Now, again, a plug for the Dandy Hub. The bandwidth that you get on the Dandy Hub specifically, I've recorded at a minimum of 150 megabytes per second, which is like super fast to me.